So we've talked about variables, blocks, functions, input and output streams, the main method. But even with all those tools, we can't really change what our program does if it sees different inputs. To handle that, in this video we're going to talk about flow control using compound statements, which are blocks of code with attributes that control their execution. We're going to talk about a few categories of compound statements today, the first of which are called selection statements, and the simplest of those is the if statement. So here's an example of an if statement. An if statement is simply the keyword if, followed by a logical expression inside of parentheses, followed by a block of code that we want to execute only when the logical expression evaluates to true. So here we have a variable money in the bank, showing us how much money we have in the bank. And we can ask, if the money in the bank is equivalent to 0, then we're going to run this block of code, which in this case will print out a warning saying we have no money in the bank. If money in the bank is any value other than 0, this block of code won't execute. We'll just skip it and go on to the next statement. Else statements always follow an if statement, and they give us an alternate path for when an if statement's body is not selected. So we've extended the last example, and again, if money in the bank is equal to 0, we'll see warning, you have no money in the bank. But now, instead of just skipping that block whenever money is not 0, we have another path that will execute, giving us a, hey, everything's good, you've got money in the bank message. Note that this block that follows the else statement can be any other statement, including another if statement, and this gives rise to the nice else if pattern. And here we've extended our example one more time to fix a bug. Now, if money in the bank is equal to 0, we get the same warning, no money in the bank. But now we catch the case, if money in the bank is less than 0 and we have negative money, we get a warning that we are in debt and have negative money. And only then, if both of those if statements fail to trigger, do we get the everything's good, there's money in the bank message. The last selection statement we'll talk about in this video are switch statements. Switch statements select one of multiple paths based on an integer key value. And here's an example of a switch statement. We have our key variable, team index, right now set to 0. We pass that variable into the parentheses for the switch statement, and then we have a series of case statements. Each case gives a value that it corresponds to and has a section of code to be run when that value is passed in. So whenever team index is 0, we print out BattleBots. Whenever it's 1, we'll print out Outreach, and so on. And because enumerating every possible value for an integer would be incredibly difficult, we have a default case. So whenever all of our previous cases weren't the right choice, the default case will get run, and we'll print out unknown team. Pay attention to the break statements in each of these cases. Without these break statements, the code would jump to the right case, but it would keep running through all the cases after that one too. So if team index were 1, we would correctly go down and print out Outreach first. But if these break statements weren't here, we would continue through the rest of the cases and print out IGVC and RoboCup and RoboRacing and unknown team as well. The break statements tell us when we're done with a case and can go out of the switch statement and continue on with the code. The next category of compound statements are iteration statements, and the simplest of those is the while loop. So here's a while loop. It starts with the while keyword, it has a condition expression inside the parentheses, and then it has a block of code to execute. As long as this condition expression is true, it will run this block over and over and over again. So here we have this random number variable. We're going to continue updating it with this getNewRandomNumber function until it equals the value 1999. Then we'll kick out of this loop and continue with our code. The other common kind of iteration statements are for loops. For loops are geared for counting. So here's an example of counting with a while loop. We initialize our count variable with the number we want to start counting from, in this case 0. Then we have our while loop. Our condition expression sets the value that we will stop counting at. In this case, our expression count is less than 10 means that we will count up to and include 9 and then stop once count equals 10. And then inside of the loop, we have a count plus plus, and this sets the step size of our counting. In this case, we add 1 to count for every iteration. So it'll start with 0, go to 1, go to 2, all the way up to 9. Now this works, but it has some drawbacks. There's no telling if someone who comes back to maintain this code will accidentally add lines between the initialization and the while loop. And you might have a big, long, complicated body here that actually does something with the count, which means that count plus plus could be out of sight farther down the file. there's no way for us to look at all the different parameters of our counting operation at the same time as our code gets more complicated. This makes maintaining this code more difficult. Luckily for us, for loops were invented to give us an easier way to write code that follows the counting pattern. So here's a for loop that does the exact same thing as the counting while loop example we just wrote. We can see again we set a count variable equal to 0 in our initialization section. We have a section for a termination condition where we check if our count is less than 10 so that we're only counting up to the number 9. And then we have a section that runs in between each iteration, which we're using to set the step size, in this case adding 1 to count. All 3 phases of our counting operation are in the same line. So it doesn't matter how big this body gets, we can always see all of the parameters at once. The last category of compound statements we're going to talk about in this video are jump statements. And you've already seen the first one, break. You got a taste of what break does when we talked about switch statements, but it can also be used in loops. Inside of a loop, break will end the loop regardless of the value of the condition expression. So here we have another while loop example, and this time we're looping until our random number is equal to 2019. But inside of our body, we've added an if statement, and the condition for this if statement is if random number mod 2 is equal to 0. In other words, if the random number is ever even, we're going to break early. So the while loop will continue running and running and running, and it will continue updating random number with the getNewRandomNumber function. But if our variable is ever even, it will stop the while loop. So our random number at the end of this loop might not be equal to 2019. It will either be 2019 or it will be even. The other jump statement we'll talk about is continue. It also works inside the body of loops. Continue skips the remainder of the current loop body and jumps to the next iteration. Let's look at an example. So here's an example of what it might look like to be iterating over a 4x4 matrix. We have one for loop that iterates over all 4 rows, and we have a nested for loop that iterates over the 4 columns of the matrix. But let's say in this example, we don't want to touch any of the elements on the main diagonal of the matrix. So we have this if statement, and the condition expression is r is equal to c, and our row and column will only be equal when we're on that primary diagonal. If that's the case, we continue. That will mean that we'll skip whatever it is we're doing normally at position RC and move on to the next iteration of this innermost for loop that loops over the columns. Whenever r is not equal to c, we'll go ahead and run do something at position r, c, and do whatever it is we're doing with the matrix. Note that both break and continue only affect the immediately enclosing loop. In our matrix example, only the loop on the variable c is affected by the continue statement. So to recap, in this video, we've talked about 3 categories of compound statements. In the selection category, we talked about how if can help us control if a single block of code is executed or not, how else can extend if to give us an alternate path, and let us use the else if pattern to choose multiple paths based on arbitrary conditions, and how switch let us choose one of multiple paths based on the value of an integer variable. In the iteration category, we talked about 2 types of loops: while loops, which let us run based on a single condition expression, and for loops, which give us a little bit more structure to ease counting. And finally, in the jump category, we talked about break and continue, which each give us a different level of fine-grained control over the execution of loops. In the next video, we're going to talk about classes and how to use objects in C++.